All right, we are recording. Marcel, take it away.
Okay, so welcome to this week's or this month's episode of the Telemetry Working Group. Looks like folks are getting back from their well-deserved summer PTO, and now we're transitioning into fall and winter time already. So we get a larger group of people this time around, and I'm super excited to have Sally here, who talks about how we can enable tracing in Kubernetes, because that gets us a little bit closer to the point where we actually collect meaningful data and we create something that we can work on in this working group. And because, well, without data, you can't do any experiments. And once we have a cluster that is enabled for experiments, hopefully we can create those experiments there. So that's super awesome. Raja, do you also want to say something, or should we hand over the floor to Sally?
No, I'm good. I'm super excited to hear this too. So
cool. Then here you go. Thank you.
So first off, I'm Sally, but Parul Singh, who's also on the call, she and I have been working with OpenTelemetry really over the summer even. The reason we've been working with it so long is because we've been working through it as it's become more stable. So we wanted to add tracing to cryo, but we couldn't really complete that until it was at a certain spot. And so that is finally now a possibility that it merged and you can trace from cryo. Let me switch over to my slides. I'm skipping, we gave this presentation, and Parul's here and she's going to answer questions, but I told her that she didn't have, I could take it. But we gave this presentation a few times, and I'm skipping some slides because I'm assuming that everyone on the call kind of knows what observability is and what a trace is. Yeah. So again, we've been working with OpenTelemetry over the summer, and I'm getting my bearings. It's the result of two communities that came together, Open Census and Open Tracing. Maybe you've heard of those two communities. Back in 2019, they realized they were kind of going toward the same thing, and it made more sense for them to come together, and that's what they did. So that became OpenTelemetry, and ever since then, it's really been a project that is growing and becoming more used and more popular. So we did a few things to drive OpenTelemetry in Kubernetes. We'll talk about our contributions and why and all of that. So a few years ago in upstream Kubernetes, a KEP was opened to enable distributed tracing in object life cycles. So it was too broad and too scary to instrument everything at once. So what ended up merging was the instrumentation for OpenTelemetry tracing in just the Kube API server. And even that, like I said, it took over a year of reviews and such. So that's available now as an experimental feature, just as of the last Kubernetes release, which is 1.22. And then at the same time, etcd added instrumentation for experimental tracing in their last release. So the etcd that is included with Kube 1.22 also has tracing capabilities. Debugging Kubernetes is really hard. It's really complex and distributed, dozens of services and components and different nodes and machines working together and communicating. And it's hard to debug. When you hit a problem, every cluster has logs and metrics enabled. So usually you dig into some logs, but you need to know which component you need to look, you need to have an idea of what's going on first. And then you might get some symptoms in this component logs, and that will bring you to the next place. But it takes time, and it's not easy. And also with metrics, you can look, say you have a regression, you can see that something's off with a metric, but metrics don't give you the information that makes it easy to find the root cause of something. It just lets you know there is something wrong. So that's where tracing comes in, and that's the gap that tracing fills. So yeah, we enabled it in Cryo, and I can show you that in a bit. We also have a KEP open to similarly to how the Kube API server is instrumented. We're trying to do that in the kubelet, and it's within the past few weeks it's gotten a lot of reviews and interest. So I'm confident that it will be merged in this 124 release, the one that we're working on now. And soon after, hopefully the code to actually instrument it will be, because we're working on that at the same time. And so once the kubelet is instrumented, we'll have this nice picture, this nice chain of requests going from Cryo, kubelet, kubelet to API server, etcd. So we'll really start to get an interesting view of requests. So enabling these features in OpenShift is a whole nother problem or issue, or because OpenShift doesn't just by default expose all of the options in upstream Kubernetes. It's very opinionated. It's also very much regulated, so that if you can't really change it too much, and that's by design, and it's great. But for development and for experimenting, it can be tricky to try out new things in OpenShift. So I think I mentioned we have an enhancement to expose these options in OpenShift, but it'll be, I think it will be slow going. There is interest, and we'll see. I have an idea of what needs to happen to do it too, and we can talk about that in a little bit. We want to enable these feature gates in OpenShift. And also, Parul and I had a really difficult time just putting all of this together, because a lot of the things we find online are outdated because the project is moving so fast, and it was a moving target trying to put the pieces together to collect the traces. So we've been publishing. We have a blog. We have some demos. We've given some talks. So we're trying to help out in that way. Just quickly, just so you have a picture of what's going on in Kubernetes, Cryo runs as a systemd service on each node, and so does the kubelet. But Cryo isn't really part of the cluster network. The kubelet is, and so kubelet kind of is the bridge between like the host network and the cluster network. That's kind of how I think of it for tracing anyways. And in case I haven't explained it already, or you didn't know, Open Telemetry, it's an observability framework for really specialized for cloud native software applications. It's a set of tools, APIs, SDKs, for all the different languages. And it's a protocol. It provides a standard data format that can be shared among the whole community to generate, collect, and export data. And tracing is stable. Metrics is also stable, but newly stable. So it's probably still got some things that will change. And then logging, the community is working on. So eventually, with OpenTelemetry, you could instrument your application for metrics, logs, and traces, and then be able to correlate all of that data, like because it's similar, same format, and then you can export it to like many different backends. So that's the idea with OpenTelemetry, is just making observability easy. It's allowing the vendors to focus on the interesting things, like, you know, the analysis and the visualization of the data, where the community can handle this, you know, generic, like how do we generate and collect and export the data to the backends. So in order to collect, you have to instrument your application. And that is done through the OpenTelemetry API and your language SDK, whatever language you're using. We're always using Go because everything that we work on is written in Go. Then that creates the telemetry data. Then the exporting is also needs to be put into the application. And once the instrumentation, then you can configure a collector, and we use the OpenTelemetry collector to receive and process and then export the data. So yeah, I think I already said all of that. And then once you goes through the collector, that's when you can export it along to see it. And we'll show this more in a few minutes. And in the collector, here's a view of the pipeline. So you have receivers, say you have metrics, logs, and traces, and not just traces. So different receivers going through the collector, being processed, and then going out to the backends. And this is kind of what a config map in Kubernetes looks like to enable the export. It's very simple because it's standard. You know, it's OpenTelemetry provides this simple standard way to handle telemetry. And again, just another picture of Kubernetes. So here's Cryo and instrumented. In order to collect from Cryo, it's a bit tricky because there's one running on each node. So what Parul and I did, we used a daemon set OpenTelemetry collector. That when you have a daemon set, one application is on each node. That's what a daemon set is. So we have an OpenTelemetry collector running on each node with enabling the host network because it has to be able to communicate with Cryo. So this agent collects the data from Cryo and then moves it along. This is one node here, moves it along to a single collector running in the cluster. And then from there, all of the nodes datas, all of the nodes traces are combined in the single collector and then exported out. So with multi-node OpenShift or Kubernetes, it would look like that. So yeah, our goal is to just show all of
Sally,
this.
I just wanted to add one thing over here.
Oh yeah, please, Parul. Yep.
Yeah, please go to the previous slide.
Oh, sure.
It's just because this was something very confusing to me. Like, you might wonder that the collector and the agent are two different code or binary, but they are not. They are the same, exactly the same thing. It's only, so when you're sending the traces from the node, we don't want time lapse, or we don't want packets to be dropped. So that's why we have each of the agent deployed on each of the nodes, so that as soon as they get the telemetry data, it's not at the node, it's not at the agent, they export it directly to the collector. So the collector has all the traces that's coming on from the node, and the collector sends it to the Jaeger or whatever viewing tool you want to see. But don't get confused, it's just different means of deployment, but they're the same components. The collector and the agent, they're exactly the same thing.
Yes.
That's all. It was
Yeah,
confusing to me. Sorry.
Same. Yeah, that's a really good point, and thanks. So yeah, so this is what is possible now. It will take some work to enable this in OpenShift. And I have some notes that I want to share with you, if that's okay, to talk about how we can do that. Let me just make sure I didn't forget anything. I can share these slides. There are some resources at the end. I'll have to transfer them to my personal account though. So yeah, I'm going to end this slide presentation. And here's, I want to go through some notes, and then I'll show you some traces in a kubeadmin cluster. So the current status again is cryo, etcd. There are gRPC interceptors, and that means that every gRPC call is wrapped and with open telemetry tracing. So you get a trace with every, you get a span with every gRPC call. So the API server is also instrumented, and with tracing, I guess this is what I wanted to talk about, the best practices. So it has to be, especially for OpenShift, it has to be configurable, has to be able to be turned on and off easily. And some components that will be easier than others. Like cryo is pretty easy to enable and disable, and system CTL restart cryo. Other components, it will take some thought. And in OpenShift, I have an idea of how that can be done. But another thing is the sampler. I didn't talk about that in the slides, but in the instrumentation, you can configure a trace sampler, and by default, we set the sampling rate to 0, because what that means is only sampled calls will generate a trace. It just cuts down the overhead from tracing. You can also configure this to be 50% or 100% in cases where you're really debugging something, but generally you just kind of want to have an overall picture. So as the chain of events is happening, you get a trace if the parent call is instrumented and sampled. And then if you either have the sampling rate set, or the never sample. I got those a little confused. So the never sample is by default, and that means it will only emit spans if the parent request is sampled. If you don't have never sample, then you want to set the sampling rate to be greater than 0. I mixed that up a little bit, but I hope I clarified it. The collector URL for OpenTelemetry that we always use it's just the default gRPC collector URL, a port 4317. In Kubernetes, upstream, we're going to add a central location for a tracing config. And that will mean that all components in the future will be able to just use the same tracing config. So it'll keep things uniform and easy to add new components tracing. Right now, Kube API server is kind of in its own, it's in a state where it couldn't easily be shared with other components. But with Kubelet, we're going to move that over to a central location. And this is like the component base is a library that is shared among components. So we want to find out in a test environment, like, where does tracing make the most sense? Is it worth the effort, the overhead? We don't really know, because we don't have access to a cluster where we can really test it. What types of problems can it solve? We have an idea. I see bugs coming through, and I think, oh my gosh, tracing could totally solve that, but we haven't tested it. Is there anything to look out for? What about the interaction between an instrumented application running on Kubernetes, interacting with the core components? It's just something we haven't experimented with. The different types of access to the traces, we need to look at that. So in order to enable this all in OpenShift, Cryo is pretty easy. You can make it, you just can add a cryo comp file here and then systemctl restart cryo. It's not destructive. Really, I wouldn't recommend doing it in like a critical production cluster because, well, I never have, but it doesn't break anything to just restart cryo, and you don't lose pods or anything. So this would be the first thing that we could enable. In the future, all of these will have a field and a CRD. I'm going to try to show it. I think this is the right. There we go. Yes. So let me see. What am I looking at? So the component that controls controls cryo is this machine config operator, and it exposes a few fields that you can configure in cryo, and that does not include tracing obviously yet, and I can't find them because I don't think this is really the right thing, but it's like I can't remember what they are right now. Oh, here, the PID limit, just a few things, the minimum log size, those are exposed in a CRD that you can, as a user, you can update. So it would be nice for all of the CRDs that control each component in OpenShift to have these fields exposed. That's the way that we'll do it in OpenShift. And same with etcd. So just real quick now, OpenShift is controlled by, it's just operator driven. So every operator has a custom resource definition that it manages, and you can't even change the operator because there's a top level operator that's making sure that there are no changes to the mid operators. And so it's just tricky to enable stuff in OpenShift. Okay, so I have some questions, and you all can ask me questions too, but with operate first, what are the clusters like? Like, do we always just take a nightly release, or is it the last release? How many clusters do we have? Could we have a cluster where we kind of very nicely hack a few changes to enable tracing? Could we have like a separate cluster where we publish that patch that we made in order to enable everything, and then it'll be able to be checked out by everyone? I don't know. So those are the questions I have. I'm gonna stop sharing, and you get. Oh, I forgot one thing. Do we have a couple more minutes?
Yes, you have still 24 minutes.
Okay.
34 minutes left.
Okay, cool. So be thinking about those questions, because I am not familiar with how operate first is, rolled out, but that's what I'm hoping. And so here we have a kubeadmin cluster with it's like an all-in-one single node cluster running on my local VM. Well, it's in GCP VM, and I have enabled tracing in API server cryo and etcd. So I have an application running that I'm going to scale it off on the side. You can't see me doing it, but I'm going to scale it to like 25 just to generate some activity here. So you can see that the cluster gets a little busy, or you should. Yeah, I guess. Let me look at the cryo. So you can see the API server and etcd are together, but cryo is off on its own, and that's because kubelet is not instrumented. So the chain's broken. So you can see, like, you might look at this one span and it might be super long. It's not, but you'd be like, what happened here? And then if cryo is instrumented, you might see, cryo might take up just a sliver of the time, and the kubelet takes up the rest, and then that something's going on in the kubelet versus something's going on in cryo. That's the idea that I have about how tracing can be used. So yeah, we should have seen like more traces being generated. Yeah, there they are. Okay. So yeah, so here's these are all the gRPC calls in cryo. They're just being intercepted. We didn't add any like specific spans anywhere. It's just the interceptors. And again, with etcd, you can say, well, let me generate some more. Let's look at a span that has both etcd and API server. Okay, so let's look at this one. So you can see like, that's the idea. Well, etcd doesn't take up much time, but I mean, I'm not good at analyzing traces, so that's why we need to get it going so everyone can use it. And yeah, so that's what I wanted to show you. Any questions? Anything you guys want me to dig in here with these traces?
Wait, Sally, what's the default sampling rate you're using for all your requests?
This one I just bumped up. I think it was pretty much 100%. But the sampling rate by default, when this is enabled, will be 0. And that I was a little confused before, and I have to check my notes, but it's because it's not really 0. It will generate spans if it gets a sampled request. Does that make sense to you, Raja?
Yes, but like there should be some flag that sets the rate of sampled request itself. So I think there's like a default rate that like applies to like the entire request.
Okay.
And then there should be a rate that upsamples different spans. So like you get like a 1 out of 100 of all requests are sampled or something.
Yeah.
And then there's something that will say that like for this span or something, right? Like either increase the sampling rate, because somehow the specific span is super important, regardless of the request sampling rate. And then there are different types of request level samplers. So there's one that's like 1 out of 100 requests. Another one's like throughput based. It's like, like sample 5 requests per second or something. So like it might be interesting because like getting that basic sampling rate to something decent is important.
Yeah.
Right?
Yeah. If we're going to enable tracing by default, we need to figure out what sampling rate would make sense exactly. And I have no idea. But there are a few fields, I talked about that tracing configuration that's going to be shared among all the upstream components. And it's also in cryo, and it just exposes like 2 fields. One is the sampling rate per million. And so I think here I just set it to like 999,999. And then the other one is just the endpoint. So where the collector, is listening. And that's for us, that's always localhost 4317 or 00004317. Those are the only 2 fields, but like if it makes sense to expose something else to make it configurable, like we can do that. But
and what I actually asked this in the chat too, and Pearl had a good answer, but I'm actually curious, like as you're adding tracing to Kubernetes, did you are there aspects of open telemetry that like don't sit well with the Kubernetes maintainers? Like I know I've had a student trying to add like open telemetry envoy, and like OpenTelemetry has its own say in how threading works, and Envoy has its own say in how threading works, and they don't work well together. And then there's something about curl, which the Envoy maintainers see as like a threat, and like OpenTelemetry uses it. So I'm curious, like, it's interesting that tracing intrudes on the application, and so like encourages these fights. So I'm curious if you ran into these issues.
No, not yet. I'm following sort of the momentum. We're following the momentum of upstream, and that is OpenTelemetry. And that's what we're working with. But yeah, there definitely are.
We're not sure. We never encountered anything related to controlling the threading, but since the OpenTelemetry started in Kubernetes and it was recommended by the SIG store chair, so I don't think so. In my opinion, there would be any struggle of rejecting OpenTelemetry or OpenTelemetry not going with the Kubernetes components. I guess we are safe in that part, if that helps, Raja, answering your question.
But like Parul said, the SIG instrumentation, the special interest group, they have community meetings, and I'm sure that they would love a discussion on this, and we could really, we could discuss this and figure out if there are caveats that need to be addressed.
And do you have a sense of like you had one slide that was like, we hope to understand what we could use tracing for. Can I reverse that? Like, what do you hope to use tracing for?
Yeah. So with latency issues in Kubernetes, they're really difficult to pinpoint. And I was on a team within OpenShift that managed the core components a few years ago. And so it would constantly be this battle of, oh, there's a regression, something merged last night and all of a sudden everything is slow, or like everything is just broken. And it doesn't happen very often because we have insane CI, but it does happen sometimes. And it's impossible to figure out quickly what happened. Even if you have the Git history of all the components, you look through the logs and one team is pointing the finger at the other team and sending the bug along to them, and they send it back to a different component because you don't get the complete picture that tracing can provide by like propagating the context. So it's just to make debugging easier and faster. Does that make sense, Raja? Is that like a use case for tracing that you think?
Yeah, it's a standard use case.
Yeah. What other ones can you envision?
When we talked about, well, the way tracing has panned out in industry has been kind of different than the way like us academics thought about it back in the day per se. But like there are different use cases for tracing, including things like attributing like resource usage to like clients, finding ways to like modeling. Like anomaly detection is like usually a different use case because like, you can't sample, right? So finding like rare things is harder. So like there are a bunch of different use cases, and like how you design the trace infrastructure kind of differs.
Oh, I see.
For
Yeah.
those things. I think as long as you're looking at like steady state problems, in the sense that like it shows up in a larger number of requests, I think tracing is easier to use. I think that sometimes the way OpenTelemetry is designed, it's really like designed for like requests that execute synchronously. Like if you have like lots of asynchronous behavior, like it's sometimes using tracing is harder because like then your response times and the work done for that request like don't really mesh. So it's hard to do stuff top down. Like, oh look, this work took a long time to perform, but all my request times look really short because, you know, like that loop between, you know, what you asked for when it completed is not reflected in your request trace, in your request response time at all. So like there's certain coding design patterns that make tracing harder to use. And I'm actually kind of curious if Kubernetes exhibits any of those, or whether it actually kind of like fits into the model that tracing is more suited for. So if you have lots of like synchronous calls, it makes sense. If you have things that like lots of like concurrent threads, like in a storage system, you might be like, oh, look, let me issue a request to like 5 different storage nodes, just wait for the fastest one and then return that data or something.
Yeah.
Like that synchronization, or like that notion of like, I only have to wait for one thing, or I have to wait for everything, is really hard to express in OpenTelemetry. So like this notion of concurrency and synchronization is not, the support is not there in the data model. So if you have those type of data patterns, then like tracing becomes less useful. So I'm curious if like Kubernetes actually exhibits these things or not.
Yeah, that's interesting to think about. And Kubernetes has synchronous and asynchronous requests all over the place. It's yeah.
Okay, yeah. That might be a fun.
There's one thing that I want to mention. KubeCon just happened last week, and there were a few really good talks on OpenTelemetry. There was one with a guy from Splunk, and it was on, and a couple of other people, and it was on correlating data with and how OpenTelemetry, if you have metrics, logs, and traces together, how they really can complement and make like finding issues and debugging them a lot easier. So I would recommend, I think you can get those talks now for free, I think. And if you just Google the OpenTelemetry KubeCon 2021, you should find it.
Okay, cool.
And they have a few use cases there that they went through with an app, like a application, like a retail application.
Yeah. If this is deployed and open in Operate First, I'd love to grab the data and try and use it for some of the work we're doing. That would be very cool. We did a lot of work trying to instrument OpenStack, but that seems to be something people are no longer interested in. So if we could use this instead, I think that'd be very cool.
Yeah, I have we have a really good idea of how we can enable this in OpenShift, but until the OpenShift people like agree to expose it all, then it would have to be a bit of a hack just to make it happen. So, and that could, if we do that, then that would encourage OpenShift probably, if the results are good and it's interesting, then they would move it along faster. So I don't know if it's possible in Operate First, though.
Yes. So, I mean, since this is not a real Operate First meeting, but we can still hijack the time to talk about it.
Oh, Marcel, I can't hear you. I think your volume is a bit low.
My volume is super low. How's that? No, I muted myself. Now I'm back.
Yeah, better? That's better.
Okay. So, I mean, Operate First started out as a Red Hat centric environment, but that's only due to the cause that it's mostly Red Hatters doing this and that we have OpenShift available. But there are no constraints that it has to be all product specific or Red Hat specific. So we can still deploy vanilla Kubernetes there if somebody is able to deploy it. And as a fact, we have micro shifts being deployed on CNV on KubeVirt there. So if you are able to deploy a cluster with tracing enabled, a Kubernetes cluster in a VM, you can request a VM and enable it there. I guess then still the question remains, how do we store that data, the traces for long term, so that Raja can access them? So we would need somebody to install a backend. I don't know where you usually store open telemetry and what's the best thing. So if Splunk was on stage, I guess Splunk is a backend. Is Elastic also a backend? Can we store it in Loki? Can we store it in just in S3 buckets? Do we have somebody to deploy Jaeger? So it's always a community. And I mean, we have folks here on the call. So if somebody volunteers to set up Jaeger in that environment, we can do it right away.
Yeah. And I can definitely help with that. And also I know some people who can make it happen too. There might be some upstream people who are interested in it and just having it running. Yeah.
I think that would be super interesting to have it just running there and then have your demo application being executed against it. And then also maybe some real applications forward looking, but still having the demo application running against it with some longer samples or long-term storage of those traces also being available. And then you can do things, okay, just upgraded my cluster from that version to that version. How did that impact the performance of these things? Or how do I, what about coverage of the tracing bits, right? Right now, it's just, you showed 3 areas where it's being enabled, which is not very much, I guess.
Yeah. The upgrading, it would be really interesting to see where things get hung up with cryo, and sometimes they're the names, the pods can't delete because they're stuck in terminating until certain things are finished, and you could really visualize all of that and see if there's something that could be, improved there. Yeah.
Is it as you mentioned, it's they had a sample application at KubeCon. So is this part of tracing that you're working on also for end users of the platform, or is that more geared towards the platform developer? So somebody who's working on etcd or kubelet, or is that also for people that deploy your average microservice application there?
And with my experience, it would be for the platform, just because that's what I know and what I've, what my experience is. And I know that the people that I've worked with would get a lot of benefit from having the information. But running different applications on the platform, I would love to see, if they benefit just from having the core components instrumented, even if they aren't instrumented, like if you have an admin privileges, could you look at the trace data from your application from the core components and get information about your application running?
And do you see a lot of not really pushback from the core, or what's the average adoption or interest from the Kubernetes community on tracing? I mean, it's really, they are really late in the game to adopt tracing at all, right? So if it's just starting right now to add it to some of the core components, they are way behind I don't know whether it's way behind the adoption curve. Maybe tracing is just starting out. But if you look at this Jaeger stuff and now these 2 communities merging, there's already some consolidation. So is that most of the folks are saying, oh, finally we're there, we just don't know what to do with it? Or is that
that's how I would describe it, actually. Yeah, they're if just judging from KubeCon, there were more than a few talks just on open telemetry, and the past few KubeCons, there's been more and more. There is a lot of interest, growing interest in open telemetry.
And for long-term storage, do you use anything for storing these spans
No.
long-term? No.
No, like I think I mentioned, I don't really know what to do with them once I get them. Parul and I are just working on instrumenting to make it possible, and then we'd love other people to join in.
So you worked on instrumenting those three components, etcd and Cube, the API server and kubelet, right? Was that
really the cryo and kubelet? Yeah. And then with etcd and the API server, I think not many people have been enabling it and trying it out. So that's what we've been doing also.
But that work is happening upstream Kubernetes, correct?
Yeah. Yeah.
And are there many other folks from the community collaborating with you on that?
Yeah, the developer from Google, his name's David Ashpole, who he added instrumentation to the API server. He's helping with the kubelet stuff. And then the Ilana Hashman, she's the SIG instrumentation chair. She's been reviewing things also. And this week we'll be that'll be up for discussion, the KEP, to see if it can be pushed through in the next round.
Cool.
Yeah. But yeah, we're just generating interest, and I don't know how useful it'll be. I'm hoping, I mean, there's some people who know a lot more than me that are pushing for it in the upstream. So I'm assuming that it will be useful to a lot of people, but we'll see.
Yeah. So maybe that's something that you could propose or ask for in the SIG tracing at Kubernetes, if there's some interest in doing that, or maybe somebody from this call knows how to spin it up or install it in that environment.
Oh yeah, for sure. Yeah. And who would I reach out to? You or the support, the support repo?
The support repo is always the first get-go,
Okay.
and I can channel things. So all I know is that we have resources available. It's just a matter of somebody actually deploying something and spinning something up. So I don't know how to install Jaeger or something like this.
It's super easy in OpenShift. Actually, it's in the operator hub, and you just click a button and it's, deployed. Yeah. It's really the open telemetry collector. They're working on an operator, and that is now an operator hub, but it has some limitations. We haven't been able to really use it. We just do deploy manually with YAML files.
Yeah.
Yeah. So yeah, the SIG instrumentation call will definitely bring this up. And once it is running, then we want to get it out there, right? We want to tell everyone to come try it out. Is that the idea with Operate First?
Yeah, I mean, the idea with Operate First and also with this group here is to create community around collecting metrics, logs, traces, incidents, all the operational data that is available for introspection and for research. So we have folks here from the research part. Raja pointed out some ideas that he could do with it, but obviously those researchers want to get the data before they write any papers.
Cool.
We could do it the other way around, by the way. So you write papers and then we bring you the data, but that's not the way it works. So I think that's still a missing piece of the puzzle. So we have a lot of folks working on software. We have a lot of folks deploying software in a proprietary way, but nobody's deploying software in a truly open source way so that everybody can look at the data being produced. Yeah. So if I would go to the SIG instrumentation group, and we can do it together. We can say, look, we talk to this in the telemetry working group. There is some interest from the research side. Here's this operate first community, and here's actually the GitHub issue where we propose a setup for having a long running cluster with tracing enabled, with a sample application being executed continuously, which is being upgraded all the time. And then you collect those traces long term, and then you can do all the fancy data science stuff on top of that, like measuring how traces evolve over upgrades, how latency is impacted, etc. And that's all those questions can be asked in a data vacuum, so to say, but if you ask them with data available, you actually can drill down to answers, and that's, I think, what's missing.
And yeah, and Raja, your research can really help upstream Kubernetes, because we have implemented it one way, and there's a lot of momentum around that one way. So, you know, let's collect some data, and then you might take it and say, well, you know, you might want to think about this instead, or, you know, this could be a lot more useful if you did this. Those are things that no one that is working on it now knows. So
I think I might have sent you this in the past, but there's one paper we published 4 or 5 years ago that tries to understand tracing design and where it fits. I can put it in the chat window. It's very conceptual, but I'd love to just chat. Maybe if you could take a look at it, we could chat about it at some point, because it might be a starting point for these type of discussions. Let me put it in the chat here. Use the brown one. Yeah. We do a lot more. We also do like a lot more advanced stuff around tracing, but like sometimes I feel like in like the open source community, like just getting tracing up and running itself is like such a challenge that we never get to these advanced things.
yeah.
So I'd be very curious about how we can get to these advanced things as well. And I'd like to use operate first as like a driver for that if possible. So that would be fun to chat about as well.
Yeah.
But yeah, if you, I'd love to, maybe you can chat in a few weeks or so. If you're able to, like, at least, maybe just look at a few pages of this paper or something.
For sure. Yeah.
I do think one of the disillusionments with tracing comes across when like people think of tracing, especially like open telemetry, as like a one-size-fits-all solution for everything. When reality, like that span-based model was really designed with a couple of design patterns for writing code in mind. And now folks are trying to generally apply it to like all sorts of systems. And so you end up with these mismatches, and people are like, oh, look, my traces aren't useful. And it's like, well, yes, the data model was not designed for the system you're applying it to. And so of course it's not going to be useful, right? So like, I think like ferreting out those things early is better.
Yeah, I'd like to really dig in and now that you've piqued my interest and talk to the upstream folks and figure out why, why they, because I haven't stopped to do that really. Like I said, I was just picking up the momentum and doing our thing with cryo. So yeah, let's chat in a few weeks and get some more info.
Okay, sounds good. I'll send it a follow-up email so we can find some time to chat.
I have some questions about the application that's trying to be run and operate first. It looked like the application that you did here was the underlying infrastructure by itself, right? That's what you were tracing. What do you guys have for test applications that you run on top of it? Is it all artificial applications that are being generated with some sort of parameters? How does that work? what's going on the operate first as users or as
That-
traffic generators?
Yeah, I'm wondering that too. Like,
Yeah.
are people contacting you and saying we want to deploy this, and like, are there things?
Yes, it's like this. It's so it totally depends what the usage patterns are. We have some long-running services like all the stuff that comes with Open Data Hub. So there's a Jupyter Hub available. There's some demo applications deployed there, like Elira and Kafka for streaming. But it's more driven from the people that needs to deploy something there. So it's not so in the end, it's really like a community cloud and use case driven. So if Sally wants to deploy a vanilla Kubernetes cluster there, she's driving that, and then she can use Argo CD, which is available, and the platform where CNV is deployed to make that happen, right? So it's not that we deploy stuff for the sake of deploying things, but it's always there should be some user and some motivator behind it who is driving this, which pretty much reflects what open source was the thriving force behind and the driving force behind open source. Somebody had a need to fix it, and they did it in the community because it was easier to build on something in a context what others already built upon.
Yeah, I just keep coming back to this thought that we need to get it out there. Like, I think if people knew that Operate First was available, I think a lot more people would want to use it. What do you think? Yeah.
Yes, I think so too. But I've been talking to a lot of people, and so far the conversion rate is not so great.
Yeah. Let's start with SIG instrumentation and see if we can get something started, at least for us, for our group.
Okay. Are there any other questions? No? Then thanks, Sally, for that wonderful presentation.
Thank you.
And
let me
hopefully
just end
we
with...
can, yeah, we can revisit this topic in a couple of months and see
for sure.
and see how much data we've produced.
Yeah, and let me just end with I'm not an expert in tracing or open telemetry, but I've just picked it up and I'm really interested in it, and I'm learning along the way. So that's hopefully what Operate First is all about too.
It is. Okay, thanks everybody.
Thank you.
And see you in a month or so. Bye-bye.
Thank you.
Bye, everyone.